Good morning and namaskar to all present here. And today, as we all know, that we gathered here for the webinar that is non-terrestrial networks and the next generation wireless communication. And this webinar is organized by Electronics and Communication Engineering Department, Parul Institute of Engineering and Technology, Parul University. This webinar is delivered by Dr. Manishika Rawat. She is presently working as a project scientist in building end-to-end 5G testbed project in association with the Professor Brijesh Lal at Indian Institute of Technology, Delhi. She completed her PhD from Indian Institute of Technology in Electrical Engineering Department, and she has approximate 10-year experience in academics. So I would like to request to Dr. Manishika Madam. So please start your webinar. Thank you, ma'am, for consideration.
Thank you, Professor Manju. So I will start by sharing my screen. I hope the screen is visible to all.
Yes, madam, it's visible.
Okay, so I'll start the presentation. Good morning to all. My name is Dr. Manishika Rawat. I have recently completed my PhD from Indian Institute of Technology, Delhi, in the Department of Electrical Engineering. Currently, I am working as an early doc fellow in the same department at IIT Delhi itself. The topic of today's presentation is non-terrestrial networks and the next generation wireless communication. The audience that I believe I'm targeting today, I am assuming that they have the basic knowledge of wireless communication and how it works, the basic knowledge of cellular communication. So this is the brief outline of my presentation. At first, I would give a brief introduction of how the generations have evolved in mobile communication from 1G to 5G till now. We'll be discussing in brief the challenges in the current state of the art. Then we'll jump on and move on to the sixth generation and beyond, or what we call as the next generation wireless communication. Uh, Basically, 6G is constituted or characterized as non-terrestrial networks. We'll be discussing the basic architecture components and key features of the communication. The two major important platforms in 6G constitute the UAV, that is unmanned aerial vehicles, and satellite for internet. We'll be discussing the advantages offered by NTN over the current state of the art and the various use case scenarios. So, mobile communication worldwide actually started. The first time mobile communication was introduced was around 1979, and it was introduced in Japan basically. The first generation of mobile communication constituted of only voice because it was using an analog technology, and only voice could be transferred, or only calls could be made, and phone calls could be made. So I think it was around 1980 that it was introduced in US and gradually across the world. 2G came into existence approximately after 10 years in 1991. The technology shifted from analog to digital, and therefore now, along with voice, text messages could be sent, SMSs could be shared. The technology GPRS was enabled. GPRS, that is General Packet Radio Service. This technology was now being used, and therefore SMSs could be sent from one person to another. The third generation was introduced around some 2009 and 10, and it was only around basically in India we directly saw 2G. In India we did not see 1G. So third generation was introduced around 2009, and it was a vast leap over first and second generation because now a very important factor that came into existence was internet. All the people around the world were connected to a common network which is called as internet. Texting became possible, SMSs became possible, and of course, video call was introduced in 3G. 3G did not last very long because before 3G could materialize completely, 4G was launched in around 2013 itself, and now the current network that we are using in India is 4G. The advantages or the benefits offered by 4G over 3G were, of course, high speed internet connectivity. We were having enormous data rates. The latency was reduced to as low as possible. In fact, right now, as I mentioned, that the current network that we are using in India is 4G network. The advantages were, of course, bandwidth was increased because now we have shifted towards a high spectrum. So All these advantages were introduced in 4G, and it proved to be very beneficial, especially in the current scenario when things changed and means COVID happened, and all the working shifted from offline to online. So 4G has been helping us throughout these years to maintain that connectivity. The next generation, which is called as 5G, as per the plans of research community, the plan might have means the 5G should have been rolled out by now across the world. However, again, COVID happened, life happens, and therefore the exact rolling of 5G could not occur on time. However, the advantages offered by 5G over the rest of the conventional generation of mobile communications were enormous. Since we were now moving towards a completely high spectrum, therefore enormous high data rate were means promised. We were shifting from MIMO to massive MIMO, and therefore large number of antennas could be stacked up together. Antenna arrays could be used, therefore high beamforming could be used. Directional directivity of the antenna gain, it would provide high antenna gains, and therefore high data rates were promised, and latency was reduced to as low as 1 millisecond. The applications of the 5G basically ranged from around the applications that were promised using 5G now increased from serving a high speed moving means trains to bullet trains to providing remote connectivity, conducting remote surgery, conducting remote education camps, and so on. It also promised facilities or, for example, the augmented reality and the virtual reality. So this is how the mobile communication basically evolved from first generation to 5th generation. 5G has been introduced in several European nations and part of US. It is commercially available there. However, in India, if you remember, a couple of months ago, the prototype of 5G was installed in one of the cafes in Gurgaon somewhere, where they were testing the speeds that were that they could provide during the 5G setup. So I hope that in a couple of years we will be able to see 5G. So before going into 6G, so as to emphasize upon how 6G is providing advantage over 5G technology, I would like to discuss in brief the features of 5G technology. So as I said that the research community had planned to roll out 5G across the world in 2020. However, it could not happen. The basic features that 5G provided was that it provided enhanced data rate to 10 to 100 gigabits per second of data rate was promised. The latency would be reduced to as low as 1 millisecond. The energy consumption had to be minimized, and therefore battery had to play a role there. The cost had to be optimized. Another important factor was that since massive MIMO could be was made implementable, and therefore as means the number of users that could be served using the same network had to be increased drastically. And of course, it has to provide a best possible coverage to all the possible users in a cell. So now the question arises that anyway we are talking about high data rate, very low latency, and also what are the challenges that exist now in the current state of the art. So the first and foremost challenge is that this demand for data rate is ever increasing. This demand is never going to fade away. If you remember earlier, we were just using mobile phones for connectivity and internet, but now every single person is carrying a smart laptop along with them. We are having smart watches with them. We are having smart TV in our home. In fact, the whole house is being converted into smart homes now. So it means that the number of smart devices that are parallelly getting connected to the network are increasing enormously and exponentially. It means that the demand for data rate is never going to fade away, and this demand is always going to increase. It means that this is basically pushing us towards going towards a higher means higher band now. Anyway, we are working in a few gigahertz frequency in 5G, but now this demand is going to push us towards a higher broadband service. Second and very important factor in the current state of the art is that unfortunately, or due to some lackings in the current in the conventional mobile generations, the rural or remote areas have been neglected to an extent that even during COVID, when we were conducting online classes, so there were several complaints from students who could not, who did not have the internet connectivity with them to connect to the online classes. So in fact, it has been proposed in a data that approximately 60 to 70% of the worldwide area, not just talking about India, but worldwide, approximately 60 to 70% of the area are still underserved. I will not say completely unserved, but they are underserved as compared to the metro cities that we are living in now today. So bridging the digital divide becomes very important. the aim of the 6G or the next generation wireless communication is to bridge that digital divide and provide a ubiquitous solution across the world. And the third point is to provide the connectivity during natural disasters and calamities. For example, I belong to a state named Uttarakhand, where we are constantly stuck with landslides and cloudburst. And the first problem that appears as soon as a natural disaster strikes is the loss of connectivity in terms of road, in terms of communication, in terms of electricity. So, if we could provide a solution that could provide connectivity, especially during the natural disasters, so it might be very helpful. So, one of the major objective on 6G and the next generation wireless communication is to provide connectivity during those drastic times. So one solution that occurs to every person's mind is to increase the density of the base stations that are currently existing right now. However, it has a major disadvantage. For example, the people who are living in metro cities might identify with me when I say that you will be able to identify a number of base stations within a radius of 1 kilometer. So increasing the number of base stations beyond that might not be a sustainable solution. Of course, we are living in an area of energy crunch. We do not have infinite energy that has to be maintained. And also, one thing that we always forget is that environmental hazards and the health hazards. So, increasing the number of base stations beyond that might not be a solution. So therefore, in 6G and beyond, or as we call it as the next generation wireless communication, it is currently focusing on the development of non-terrestrial networks to promote ubiquitous and high-capacity global connectivity. So 6G basically envisions a three-dimensional heterogeneous architecture in which terrestrial infrastructures are complemented by non-terrestrial stations like aerial vehicles, that is the UAVs, or drones that you might have heard of, the high altitude platforms that might include the planes, helicopters, or some other vehicles, and satellites. So basically, 6G is now shifting. In 6G, people research is now shifting from using a terrestrial communication to a non-terrestrial base station. So what does exactly NTN stands for? NTN basically stands for, uh, just a second. Okay, so what exactly this NTN stands for? NTN basically refers to a network operating through an air or spaceborne vehicle for communication. So now, as I mentioned in the previous slide, that now we are shifting from a terrestrial base station that was conventional towards a non-terrestrial base station. The base station will not be connected to the ground as per plan of the 3GPP, that is Third Generation Partnership Project, and the International Telecommunication Communication Union. So, what exactly the architecture of NTN consists of? NTN, that is non-terrestrial system, features basically a terrestrial terminal. Terrestrial terminal might be the user equipment that we are using, for example, mobile phones or the handheld devices. An aerial space station, which may operate similarly to a terrestrial base station. For example, I mentioned the UAV devices or the satellites. A service link between the terrestrial terminal and the aerial space station, and a gateway that connects the non-terrestrial access network to the core network through a feeder link. So these things will become clearer in the next slide, where we discuss in brief the what exactly that NTN architecture consists of, or all the components of the NTN architecture. So as I mentioned that first of all, we have NTN terminal, which is mentioned here. For example, I might be having my mobile device with me, any smart other device, or if I want to maintain a connectivity with a satellite, then a VSAT terminal at my end. Of course, when I'm using a mobile device, so the kind of antenna it has is an omnidirectional antenna. Sorry, the frequency of operation is below 6 GHz. It is basically installed with omnidirectional antenna so that it is able to receive signals from all the directions. When I talk about satellite communication, so we have to install a very small aperture terminal, a dish kind of antenna at the rooftops so that it is able to extract the energy and, of course, data from the directional link coming from the satellite. So the second component is the space or airborne platforms, which, as I discussed, consist of basically UAVs or high altitude platforms and satellites. The link types might be the service link connecting the satellite to the user terminal, user equipment, the inter-satellite link between the any two satellites, and the feeder link connecting the satellites to the core network, which might be a 5G or a 6G core network. So the key features of NTN communication basically can be summarized as given in the slide. First, oh sorry, can you see my slide now? So I'll continue the presentation. The first important key feature of the NTN communication is that almost every time line of sight is required, the communication is only possible through line of sight. It's not that NLOS is not possible. It might be possible, however, that innovation is so high that the contribution is almost negligible. And that is why we say that almost always line of sight is required for communication for these non-terrestrial networks. Of course, since we are talking about the satellites, which are located to 500 to 1100 kilometers distance from the Earth station, so the propagation delay is quite large. Delays are quite large, which increases the latency between the communication. Doppler shifts are huge because now we are talking about a satellite which is moving at approximately at a speed of say 1,000 kilometers per hour, and a user terminal or mobile station or a user in the Earth is moving at a speed of say they might be stationary, they might be moving at a speed of say 1 or 2 kilometers per hour. So the difference, the relative velocity is so huge, which gives rise to large Doppler shifts, which have to be dealt with while means carrying out this work or studying the NTN communication. The additional features and which become very important include the attenuation. The attenuation may be atmospheric attenuation because now, as we can see in the figure itself, the UAVs or high altitude platforms might be located in the atmosphere itself. However, the satellites that we are talking about, when satellites will be used for communication, these satellites are located in space. They are beyond atmosphere. They might be located in stratosphere and some higher other layers. So this causes a lot of attenuation when the signal propagates from one terminal to another. So all these factors, cloud attenuation, rain attenuation, scintillation, all these factors combine together to cause a lot of atmospheric attenuation. So these are the basic factors and very basic factors that need to be considered while studying the NTN communication. So this is how figure basically highlights the height at which all these platform would exist. For example, UAV, if we are installing UAV or if we are deploying UAV, so UAV is usually deployed at a height of few hundreds of meters, and therefore the footprint it creates upon the Earth's surface. By footprint, I mean the area that it will be, the area that it will be able to serve. It is hardly beyond a radius of few kilometers. Means the radius of that area will be few kilometers, say 1 to 5 or 10 kilometers. So as the height of the this NTN network or HAPS, that is the high altitude platform, increases, say around 20 kilometers. Of course, the height is increasing, so the area that it will be able to serve also increases. However, as the height would increase, we also know that the distance between the Earth station and the non-terrestrial station is also increasing. The increase in distance will increase the propagation delay, which will further increase the latency. So it is like one thing at the cost of other. Okay. So we can now start with focusing one by one upon how this UAV can be used for communication. Secondly, we'll be focusing upon how satellites, how means 6G plans to use satellites for communication, and so on. So we start with UAV, that is unmanned aerial vehicle. So as I discussed in the previous slide, that UAV are basically installed. UAV are the drones that we have been seeing nowadays. The research in UAV or drones is quite at its peak right now. There are UAVs with very small, with very less weight available now in industry. So it becomes easy to use UAV, relatively easy to use UAV to provide communication. So these UAVs basically lie at low altitudes of around few hundreds of meters. So the advantage that is basically offered by UAV as a UAV to provide internet, our first thing is that it is an on-demand network. It is an on-demand and flexible network. It means that it is an on-demand and flexible network. It means that, of course, UAV does not have to be present always in the network in the serving area. The network can be put on demand. For example, if there are disaster has been struck in certain area, or we have to set up a remote medical camp where the medical camp has to be set up in some rural area which needs to be served immediately. So for that particular amount of time, a single UAV or a swarm of UAVs can be deployed in that area so as to serve that particular area and provide high-speed internet connectivity. So this becomes a very important advantage of UAV. since now even less weight UAVs are available, so a swarm or a large number of UAVs, 5, 6, or tens and twenties of UAVs can be installed to serve a larger area. So this becomes a very important advantage that is offered by UAV. How it can be used? It can be used in two ways. Either a UAV can serve a cellular base station, which is already existing. It can provide uplink signal to its base station, which can then further serve the users which are available in the given cellular area. Or this UAV can act itself as a base station, and then it can serve the users which are present in the given area. So this is the two ways how UAV can be used. Since UAV base station. So basically, the research or the basic research that I am also focusing on right now, and the major research that is going on right now is using UAV as a base station because it poses several advantages which are quite visible to the researchers. That yes, it is means you can see that it can offer several advantages over using a terrestrial base station. So, however, as we discussed in the previous slide, that there are certain limitations of these non-terrestrial networks. Those limitations can be mitigated to an extent if we start using UAV base station using a millimeter wave band. Because what will happen is that when we are talking about millimeter wave band, we are shifting towards a higher operating frequency of around 28 gigahertz or 72 gigahertz. So when I say 28 and 72 gigahertz, these are the frequencies that are being posed as standard by 3GPP and the ITU. So what happens that as we are shifting towards a higher frequency, it poses a lots of advantages. First of all, it is providing enormous bandwidth and hence supporting humongous data rates, which is going to be the need of the hour in a couple of years. Secondly, since we are moving towards a higher frequency, the wavelength, the lambda by 2 wavelength that is required for effective radiation for an antenna design, it becomes very small, and therefore this technology enables mounting high dimensional antenna arrays upon the UAV, and it also enables using massive MIMO. So this becomes very advantageous because now since we are using a high dimensional antenna arrays, it means that the beam that will be produced, it will be very highly directional beam providing high gain. So the propagation loss that was a problem in a non-terrestrial network, it can be compensated by using this high directional antenna beam gain. Okay. Secondly, since it is highly directional, security increases, and the possibility of interference between the successive beams also reduces. This technology also enables spatial multiplexing. It means that multiple beams can be used, multiple beams in a same sector, or in the same cell, might be using the similar frequency. However, they can be addressing separate users. It means that the number of users which could be addressed now can be increased to a large level. Of course, using UAV as a base station is energy efficient because, as I mentioned, that using UAV is a flexible on-demand network. You need not to deploy UAV constantly over a given area. It can be put to use only and when required. So that is the reason that this UAV as a base station using millimeter wave band is usually envisioned as an efficient technique to overcome the coverage limitations of the existing 5G network. Not just 5G, existing all the networks that exist till now. So these are the basic advantages offered by UAV as a base station using millimeter wave band. So if you look into this figure, basically I have in this figure I have highlighted two use cases of how UAV can be used to serve the users in a given area. Um, this is just a use case scenario. Of course, if a UAV is mounted at certain height of HU, so since multiple antennas can be mounted, multiple arrays of phased array antennas can be mounted upon the UAV. Of course, the size is going to be as small as possible. So, but UAV is of course limited by the power because when we are using UAV as a base station, the power that is available at the UAV is limited. The bandwidth is also limited. So it is a resource limited. However, that power has to be efficiently utilized to serve a given area. So when the beams are being produced, these beams can be used to address and serve several users lying in a given area. So this is the use case scenario when only one UAV is being used to serve a given area. If the area is large and the footprint offered by UAV is limited, so therefore a swarm of UAVs can be used to serve a larger area, as is shown in this figure. So now we move towards the next non-terrestrial station, that is non-satellite for internet. Now this is becoming very interesting nowadays because UAV as a base station has been employed to an extent because in India we might not be using it till now, but for disaster management in the European nations, UAV as a base station has already been employed to provide connectivity and coverage, internet connectivity. So that is something already existing, but it is not that widespread. However, satellite for internet has is becoming widespread now, by the name, if you remember, a very ambitious project by a gentleman known as Elon Musk. This is the Starlink. Starlink is basically a part of the SpaceX project that they have deployed to colonize Mars, basically. So Starlink is a project by which they are basically launching satellites in the lower Earth orbit of the Earth, and the idea and motivation is to provide connectivity to underserved areas. So Starlink has already started working on this area ever since 2015. I'll be discussing the specifications of Starlink in detail in the next slides. So it is not just Starlink, but there are various other players like OneWeb. So Starlink is basically a US-based company. OneWeb is a European-based company, and it has also started launching. It has already launched a large number of satellites, and it is already providing connectivity, internet connectivity to users lying in that area. There are several other players who are working in this area, like Hughes, Samsung, and Amazon. So Hughes has already started launching their satellites. Samsung and Amazon have claimed that they will start working on this, but they've not yet started launching their satellites to for that. So now I basically in this slide I'm basically giving the specifications of the Starlink constellation in specific. So this basically will give you an idea of how this internet has been provided by the Starlink constellation and how it is serving the underserved areas. So of course, as I mentioned, the manufacturer is SpaceX. The country of origin is United States. They have till now launched 1,575, and this is I'm talking about the licensed satellite. They have actually launched more than 2,000 satellites, but some of them are in a deorbit condition right now. So the functional satellites till now are approximately 1,575 satellites, which are right now working and providing internet connectivity across 29 countries. The satellites are basically lying in a low Earth orbit of height approximately 1100 kilometers. The frequency band that they are using is around Ku and Ka band. So they are basically using greater than 12 gigahertz, 12 gigahertz and 24 gigahertz of band. Of course, the antenna technology is the phase and antenna array technology. And since, of course, the weight of the satellite becomes important here, because the lesser is the weight, the lesser is the amount of technology and energy that it will be required to put that satellite to space. So the satellite weight till now that they have been using is 100 to 500 kg. So this is the specifications uh, of a single satellite, or the Starlink whole concept of Starlink constellation across the Earth that they have maintained. As I mentioned, they're already serving 79 countries. They're serving, I think, US. They're serving most of the European nations. Australia is being served. In fact, recently, you must have heard about this news that amidst the crisis that is going on in Russia and Ukraine. So, Ukraine Prime Minister had requested Elon Musk to provide with connectivity so that they are not out of internet connection because of whatever the disaster is happening. So, Elon Musk had very graciously sent now thousands of kits of this Starlink set up, and now they have been using, they have very boasting, the president as well as along his team, they have been boasting that now the Wi-Fi connectivity is available to them. And so basically what does that kit consist of, since now we are talking about connection to satellites. So of course we are talking about higher frequencies, and the handsets or the mobile phones or the smart devices that we are using today, they're not enabled to work in this high frequency of 12 and 24 gigahertz. So how will that work? How does that work is that basically that kit that comes with the Starlink, it basically consists of a Starlink dish antenna, as is visible in this figure. So what exactly happens is that now, since satellite is located at quite far away range, it is basically 1100 kilometers approximately. So if the signal is going to come from such high distance, the propagation delay is going to be very large, attenuation is going to be very high, and therefore in that case, if the receiver was an omnidirectional antenna, the losses would have been quite high. That is the reason that now they have basically shifted towards a parabolic reflector. This is quite similar to the dish antenna that we use in TV satellite TV system right now. So basically, it has been designed so as to extract more and most amount of energy from the satellite that is coming near. So this kit that comes with Starlink, it basically consists of a Starlink dish antenna. So basically, it basically catches all the signal, and a router is installed inside the home which will be able to provide Wi-Fi, and that Wi-Fi can be used across your homes and across your usage. Now, of course, there are disadvantages because if you think from the perspective point of view, so this is what they plan to do, and not just Starlink. Starlink was just one of the companies that have already started working on them. As I mentioned, there are several companies and several players who are working towards it and have been successful in doing this. And this is what they plan to cover the whole of earth with a web of satellites. And the idea is that these web of satellites will be able to provide coverage to every single corner of the earth, whether you are not just in the terrestrial station, even if you are lying somewhere in between, if you're in between oceans, for the people who are working across marine technology or who are sailing across, so even they will be able to provide signals across it. So this is what they plan to do in by using satellite for communication. Of course, satellite communication, it seems to be very fancy. However, it has its own limitations. The first and most important limitation is that the latency is quite high, as I mentioned, because the distance is quite large. So the propagation delays becomes very large, and latency can be as high as 25 to 50 milliseconds. The cost is quite high. For example, as I showed you the setup for the single kit for that Starlink setup, it costs you around 500 USD. And this is the cost for a single kit, and the subscription fee then you have to pay it is across approximately 100 USDs. So the concept is the concept is quite interesting, but the cost, with respect to cost, it might be that useful to general mob available. The third thing is that the bandwidth is limited, because, of course, they are working in a given bandwidth, and once a satellite had been installed, it is not that cost friendly to reinstall satellite again and again, as the user demand will increase. And of course, as I discussed, that the number of smart devices are going to increase exponentially, so the demand is going to increase forever. And this will put a limitation upon the number of users that can be served parallelly with a single satellite or a group of satellites in a certain height. Of course, as the number of users will increase, since the bandwidth is limited, the amount of data rate that will be available to you, that will also reduce. This is a quite a big limitation of satellite communication. The another important that is from the environmental point of view is that with what people have been complaining is a space debris problem, because, of course, the all the satellites, for example, as I mentioned, that SpaceX has had launched approximately 2,500 satellites, out of which all were not functional. Only 1,500 some value is functional right now, and the similar thing happened with other players also who are working in this area. So this is creating a lot amount of space debris problem across the space, which can be quite problematic in future. Another problem that astronomers have been facing is that, because we know that these are man-made satellites and they are bound to reflect light. So it is creating problem for the astronomers who want to study the stars, natural stars, and constellations, and etc. So they are saying that their research is getting hampered because of these satellites which are installed across the globe. So these are certain limitations of the satellite communication. In all, if we talk about the advantages of NTNs, as we discussed earlier also, that of course it is an on-demand flexible network. You can install and deploy UAV as and when you want. The UAV can be connected to the core network via OFC, that is an optical fiber cable. It can be connected by an optical link also. However, it is an on-demand network and available flexible network, and therefore the cost efficiency increases to an extent. It can be used to serve a crowded area even in the metro cities, or it can be used to serve the unserved areas or completely underserved areas. It is cost effective and it is energy efficient. Uh, the idea is to provide a ubiquitous Internet of Things broadcasting, and by ubiquitous, I mean that all the areas should be able to have a uniformly available internet. As I mentioned, that the digital divide should be completely gone. The advantage is that it will be able to provide support for high speed mobility. For example, as we are talking about high speed trains, bullet trains, and all, so it should be able to support high speed mobility without any call drop or without any drop in the internet connectivity, and of course, high throughput services. So these are the use cases enabled by the NTN. As we can see in figure, there are several large amount of use cases. For example, there are HAPs which are serving the HAPs which are serving the rural area. The UAVs can be used for disaster coverage. Basically, the idea is not to use these UAVs and satellites and HAPs individually. The idea is to provide a complete 3G integrated model of this non-terrestrial network so that they can work all together to provide a ubiquitous solution, ubiquitous internet connectivity across the globe. This is basically I can this is basically the vision beyond 5G. This slide might appear quite visionary to many people, but it is something that people in Japan and Korea have already started working upon. The first is the urban air mobility, which might be completely overwhelmed with the UAV in maybe in a decade or whatever. So the idea is that instead of, for example, now it has been proposed that two-thirds of the world population will be by 2030 will be living in the urban cities, and therefore instead of using manual power, manpower to deliver these products, UAVs could be used to deliver goods and people. They're also proposing air taxis and airport shuttles for this purpose. And the second thing that is also a visionary project is basically these UAVs cannot be let to float relentlessly across the space or air. So therefore, there is a proposal for highways for UAV that is known as aerial corridors. They are unlikely to fly everywhere in an uncontrolled manner, and therefore there have to be some defined and regulated routes for them. So uh, this is basically all. As you can see this figure, the people have already started working upon how these routes could be defined, how these routes could be defined so as to serve the maximum number of users in a given region. So this is all for presentation today. Thank you. This is my email ID if anybody wants to contact me regarding any point in the presentation. Any questions?
Thank you so much, ma'am, for coming and accepting our invitation for this webinar. And I hope that the student understood about the satellite communication and also understood the next generation of wireless communication. And I am hoping here that the student also got the idea about the recent and advanced topic in wireless communication. Once again, thank you, ma'am, and thank you to all those present here. So thank you all and have a good day. Thank you,
Thank you
ma'am.
so much. Thank you.